All right, so in 4.2, we are going to look at modeling with linear functions. So we're going back to word problems, but we're going back to them with the idea that now instead of using y equals mx plus b, we are looking at these with the form f of x equals mx plus b, or some other format, right? They might say find mileage as a function of speed, right? So then I've got ms plus b, whatever it is. Okay, we're just following that pattern where I have a slope times a number plus a different number. Okay, now we use linear functions all the time. We just don't necessarily write them down. We don't necessarily look at what's happening. But these are all around you. Okay, anytime that a population is changing, that's probably linear. Anytime you're looking at gas mileage, that's a linear function. You're changing weight, income over time, predicting profit, variable costs, adding up your groceries. Okay, like if I'm buying grapes and they're $2 a pound, every pound that I add to my cart adds $2 to my total, right? So that is a linear function. That's a linear relationship. All right, so in 2004, school's population was 954. By 2008, this had grown to 1614. So, for part A, how much did the population grow between 2004 and 2008? Well, I would take 1,614, I would subtract 954, and we could say that it increased by 660 people. How long did it take for that population to grow? Well, I could say, 2008 minus 2004, which gives me 4 years. Okay, part C, what is the average population growth per year? So I want delta people over delta time. Remember, delta is the Greek letter that in math means change. Okay, so the change in people divided by the change in time, which is going to be 660 divided by 4, which is 165 people per year. Okay, now if that doesn't look familiar, hopefully it will in just a second, what we just found is our slope, right? Average population growth is slope. It's average rate of change. Okay, so now I have my slope. In order to make the predictions that it wants me to do in parts D and E, I need to have some sort of equation. I have to have a place to plug in a number so that I can get an answer out. And the easiest way to do this is, let's take our 2 points. So let's say in 2004, there were 954 people, but I don't really want to have to plug in a number as big as 2004, right? Mathematicians are lazy. I don't want to do that. So what I can do instead is I can set this as year 0. I can just say, I don't really want to mess with it. Let's just shift the y-axis over, right? Let's just put the y-axis on 2004 instead. And so what that does is, because I've done that, this now is my b value. So I don't have to do any algebra to figure out the rest of this equation, right? I know population as a function of time is going to be 165 times the number of years plus the 954 people that we started with. Okay, so now that I have a model, I can go to part D. What was the population in 2000? Well, if 2004 is 0, then 2000 was 4 years ago, which means it's a -4. And so we would just plug that in. So p sub -4 is going to be 165 times -4 plus 954, which I'm pretty sure is 294, but go ahead and check that in your calculator. Okay. For E, we have a similar idea. So in 2011, well, if 2004 is 0, so 2011 is 7 years later, so we're actually going to plug in t equals 7. So P of 7 is 165 times 7 plus 954, which I believe is 2,109. Okay, so don't try to avoid letting your anxiety scare you away from these big problems. Just because it has multiple parts doesn't mean it's any harder than anything else you were doing. What they're actually trying to do in this particular textbook, what they're actually trying to do is walk you through how to get all of the numbers that you need in order to solve this problem, in order to make those predictions. Okay, so the big problems aren't necessarily 5 different problems. They're trying to get you from point A to point B in this problem. All right, so a town's population has been decreasing at a constant rate. If you see anything that says a constant rate, that should tell you this is linear. Okay, no matter what, whether they say it's linear or not, if they say constant rate, right there, that's my linear function. Okay, that means that somewhere in here, I'm using some version of y equals mx plus b, or f of x is mx plus b. I know that immediately. That's what constant rate means. Okay, so in 2010, our population was 7,200. In 2012, that population had dropped to 5,600. And we're going to do the same trick we did on the last problem. In fact, anytime you have a year as an x value, I highly recommend doing this. Okay, whatever the first year is that they give you, make that year 0. So this is 0, 7,200, which means 2012 is 2 years later, and 5,600. And then just like the last problem, I want to be able to make a prediction. In order to predict, I have to have a function. So I'm going to start with a slope. So my slope is going to be 7,200 minus 5,600 divided by 0 minus 2. So it's going to be 1,600 divided by negative 2, which is a negative 800. So population as a function of time is going to be negative 800 times the number of years plus 7,200, because that's the b value I have when I made that year 0. That's why we make it year 0. Okay. So for 2016, if 2010 is year 0, then 2016 is 6 years later. So P of 6 is going to be negative 800 times 6 plus 7,200, which is negative 4,800 plus 7,200, which is going to be 2,400 people. Okay, so by 2016, we predict that there will be 2,400 people. And how correct or not would have depended on what our tolerance is, right? Brings back those absolute values. Is it a good prediction if I hit 2,300 or 2,500? Is it a good prediction if I'm only off by 5? Like, what's my level of tolerance? Okay, so that's where the absolute value formula now comes into play. All right, the weight of a newborn is 8 pounds. The baby gained half a pound per month in its first year. Find a linear function that models the baby's weight as a function of time. Okay, when they say weight as a function of time, what they're saying is make your final equation be W of t. So I'm looking for mt plus b in this case. I'm taking slope and time and b, okay, my intercept. Now this question is a little confusing to students because it's way easier than it looks. There's no numbers to plug in, there's no points, there's no values and things to track down. All you need to do is actually write the equation, okay? And in this word problem, you have two numbers. You have 8 pounds and you have half a pound. And so all we really need to do is figure out which one of those is the slope and which one of those is the intercept. Okay, and I'll give you a hint. Anytime you see this little per, okay, that is almost always looking at a slope or a rate, right? This is pound per month, which means it's a rate. The same way that we say miles per hour, okay, or feet per second. That little per is telling us that I've got a rate. It's a weird rate, but I have a rate of something, okay? So that 1/2 is going to be our m, that's our slope, which means 8 pounds has to be the initial value or the starting weight of the baby. So our formula is going to be W of t equals 1/2 times t plus 8. And that's it. That's all that question is asking for. Give me a function. Cool, here it is. All right, you are hired at a new sales job. You are given two options for pay. You can choose to receive a base salary of $17,000 with a commission of 14%, or you can choose to have a base salary of $20,000 but a commission of only 8%. How much will you need to sell for option A to produce the same amount of income as option B? Okay, they want us to know when is A the same as B. So when does A equal B? Well, in order to solve that, I need to know what A and B are to begin with. So looking at option A, and we will say that X is our sales amount. I can't spell sales. X is our sales value. Okay, so A of X, I get a base salary of 17,000, so that's going to be my B value. And then 14%, right? That little percent. It's right there. That's my rate. Now the difference is when we work with percentages in math, we never work with the percentage number. Always, 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 always change it to a decimal. And we change it to a decimal by taking the decimal place that's here and moving it back 2 places. So this is actually 0.14x. Okay, we're going to repeat that process for option B. So B of x is going to be 8%, so 0.08, and a base salary of 20,000. That is too many zeros. Okay, so now that I have them, now I can look at where does A equal B. So I'm going to take A of x and I'm going to plug it in over here. So 0.14x plus 17,000 equals 0.08x plus 20,000. I'm going to subtract 0.08 from each side. Then I'm going to subtract 17,000 from each side. And then divide by 0.06. So x is going to be 50,000. Okay. Now, just as a side point, so that you can understand what this is really asking us to do. If I graph A of x, okay, I'm going to start at 17,000, and then I'm going to grow at 14%. So there's A of x. If I graph b of x, I'm actually going to start a little higher. I'm going to start at 20,000, but I'm not going to grow as fast. Okay, so b is going to be a little bit of a flatter line. And what this question is asking is, where is this place right here? 50,000, and I don't know the y value, so I'll leave it blank. That is the place right there that those lines happen to cross. So, depending on what I'm selling, and we don't know what we're selling, if I don't think I can sell $50,000 worth of it really easily, I probably want to go with option B. Because on this side of that spot, option B is taller, which means I'm going to make more money on option B. If I think whatever I'm selling, I can definitely sell $50,000 where it's no big deal, then I probably want to go with option A. Because after $50,000, option A is going to make me more money. Okay, so the way that they're asking this question, that's what they're getting at. If my job is to sell, I don't know, dollar store items, $50,000 might be a lot. I might not hit it, as early in the year as I want to. Whereas on like the other hand, if I'm selling used cars, $50,000 is like 2 used trucks, and you could probably do that in January, right? And so after that, now you're making big commission, you're making better money. And so it just kind of depends on what the scenario is, how it works out. Okay, so that's what they're asking you to do. That's pretty much it for 4.2. So